Hello viewers, welcome to yet another interesting video under dimension analysis. So we are going to discuss about a gas bubble from an explosion underwater oscillates with the period t and is proportional to. So this that we have here, this P simply means the hydrostatic pressure. This other P is a symbol for density. Then the E is the energy for the explosion. So given this information, we are taught to find the values of A, B, and C. For us to find the values of A, B, and C, we are simply supposed to use dimensional analysis. So how it is going to be done is, we're going to let time, which is T, to be directly proportional to this atom to the pressure raised to the power A, the density raised to the power B, and the energy which is raised to the power C. So after this is done, we want to say when changing from proportionality to equality, we're going to have T being equal to a constant K multiplied by pressure to the power A, density to the power B, energy to the power C, like that. Okay, so here, there's nothing that we can do for us to find A, B, and C. So what we're going to do is, we're going to now go to dimensional analysis. We're going to find the dimensions for time, for pressure, density, and energy. So we know that for time, the dimensions are m to the power 0, L to the power 0, t to the power 1. Or it's just the same as saying t to the power 1. Then the constant k under dimensional analysis is not considered because it has no dimensions. Then we'll go to pressure. Pressure we have m L to the power negative 1, t to the power negative 2. Now this one is raised to the power a. Then we have density. We have for density is m L to the power negative 3, t to the power 0. This is raised to the power b. And we also have for energy, which is m L to the power 2, t to the power negative 2, like that. So now these are the dimensions for these particular physical quantities. Now this one is to the power c. Okay, so what is going to be done next is, here since we have A which is outside, we're going to distribute it with everything that is inside. Now this will give us, on the left hand side to be maintained like this, which is m to the power 0, L to the power 0, t to the power 1, which is equal to, so now distributing everything that we have here to the power A, we're going to have m to the power A, L to the power negative A, t to the power negative 2a, multiplied by, here we're going to have m to the power b, L to the power negative 3b, and the t which is the power 0 just be a 1, so we won't write it here. I'm going to say multiplied by m to the power c, L to the power 2c, and t to the power negative 2c. So now from here, we then consider exponential functions, where if you have the same bases which are multiplied, you just sum up the powers. So we're going to get the left hand side will be maintained, which is m to the power 0, L to the power 0, t to the power 1, like that, which is equal to, this side we're going to have m, now you have m to the power a, m to the power b, m to the power c, which will be m to the power a plus b plus c. Then go to L. So L will be to the power negative a minus 3b plus 2c. Then we go to time, which is t to the power negative 2a minus 2. So this is 2c here, minus 2c, like that. So that's what we have. Now, we then go to the principle of homogeneity, which says that if you have an equation, what is on the left hand side is supposed to be the same as what is on the right hand side. So meaning that what we have this side dimensionally is the same as what is on the other side. If this is the case, means that that equation is correct or said to be dimensionally consistent. Now again, going back to exponential functions, if you have an equation and that equation that you have, if the bases are the same, both sides of the equation, meaning that you're going to equate the powers. So the power that we have for m on the left hand side is the same as the power that we have for m on the right hand side. Same applies with L and T. So because of space, I'm going to erase the upper part. I'm going to leave this information for reference. So we have a 2a there. Now equating the powers, for m we're going to get a plus b plus c, which is equal to 0. Then come for L. For L we're going to have negative a minus 3b plus 2c, which is equals to 0. And for T, we're going to have negative 2a minus 2c, which is equal to 1. Comparing the sides of the equation. So now after this is done, we can then find the values of a, b, and c by using different methods. So we're going to prefer a solution for this problem using a simple method. So we're going to first consider this equation. Now here we have three variables a, b, and c. So we're going to let one of the variable b equal to the additive inverse of the other variables. So we're going to say, we're going to manage b, which will be equal to, find the additive inverse of a and c, both sides of the equation. I'm going to get negative a minus c. Now we're going to leave this equation here for now. We'll go to the second one. Now this second one, wherever we have b, we're going to substitute with what we have here in the first equation. So this will give us negative a minus 3 multiplied by what we have for b, which is negative a minus c. Then we say plus 2c, which is equal to 0. So we're going to continue working with this equation. Now we're going to get negative a plus 3a plus 2c plus 3c, plus 3c plus 2c, which is equal to 0. Now grouping the like terms together, we're going to get 2a plus 5c, which is equal to 0. Now if you compare the answer that we have for this second equation with what we have for the third equation, the variables that are there are the same. Here we have a and c, here we have a and c. So we're going to solve these two equations simultaneously. So I'm going to get this one and this one, combine them to solve them simultaneously. So we have negative 2a minus 2c, which is equal to 1. So for this one, we're going to simply use the elimination method. We're going to use a positive to eliminate a. So 2a plus negative 2a will just give us a 0, meaning that a will be eliminated. We're going to remain with c. Now 5c plus negative 2c will just give us 3c there, which will be equal to, when you add 0 plus 1, we're going to get 1. So this will therefore mean that the value for c is 1 over 3. Now after finding the value for c, we can then find the value of a from the system of equation here. So we're going to choose the equation which looks to be more simple, and that equation is the first equation, which is 2a plus 5. Then while there is 2, we can substitute with 1 over 3. Then we equate this to 0. Now this will simply give us 2a plus 5 over 3, which is equal to 0, which means that you're going to have 2a to be equal to negative 5 over 3. Now finding the value of a, we're going to say a will be equal to negative 5 over 6 when everything is done. So we have the value for c and the value for a. So we can go back to what we did in the first equation, where we had to equate b to negative a minus c. So here we're going to say our b will be equal to negative, the value for a is negative 5 over 6. Now when it multiplies this negative, it will become positive 5 over 6. Then we subtract with what we have for a, for c, which is 1 over 3. Now when this is done, when you do your simple mathematics, you are going to get 3 over 6 for b, which will just give us b to be equal to half. Now after this is done, this will therefore mean that we have our values for a to be equal to negative 5 over 6, the value for b to be equal to half, and c to be equal to 1 over 3. So these are the values for A, B, and C, which are here. So this is how we find A, B, and C, like this.